So in this segment, we are going to be looking at the ideal gas law, which looks at the status of a gas at one point in time. Now, when we are looking at that, at a gas at one point in time, we are looking at this equation and all of these variables. So P stands for pressure, V stands for volume, N stands for moles, volume, pressure. T should look familiar, that's temperature. And then we have this new letter R, and R right here is called our gas constant. And that constant is just kind of this number that allows for pressure times volume to equal our moles times temperature. We need to have this number right here, and it's this scientifically found number that this 0.08206 to make this equation happen. And so what we're going to look at is with this equation, there are 5 variables here, but R you will always know. So if we take that out, we then have 4 variables. And if you know 3 of these, so if you know 3, you can find the 4th. So let's look at how we would go about rearranging this equation to solve for different variables. So if we know that pressure times volume is equal to moles times R constant times T. If I said, okay, let's solve for pressure, that means I need to get rid of what pressure is attached to. And in this case, pressure is attached to volume by multiplication. So using algebra, I need to get rid of volume. So I need to divide by volume on both sides. So we would then say that pressure is equal to N times R times T divided by volume. And hopefully you feel pretty comfortable with that. But let's say if I have PV equals nRT, I wanted to solve for volume. So I would look at this and say, well, I need to get rid of my pressure then, if I want volume by itself, right? Get rid of my P, so I have to divide both sides by P. So my volume would equal nRT divided by pressure. Okay, not too bad, right? So here's my way of finding pressure. Here's my way of finding volume. What if I said I wanted to find moles? So if I know that PV equals nRT, and I want to find N. So if I want N, I have to get rid of everything that is attached to N. So I'm going to divide both sides by RT. So moles is equal to pressure times volume divided by my gas constant, R, times temperature. Now, the last variable, because again, we'll never need to solve for R, we're given R, temperature. I want you to pause real quick and see if you can show me how to solve for temperature. And hopefully you got pressure times volume over N times R. So let's try a couple of problems here. What is the volume? So remember, we're using PV equals nRT. So it says, what's the volume? Means I need volume by itself. I'm going to divide, before I even go anywhere, I'm going to divide both sides by P. I'm going to say volume is equal to nRT divided by pressure. I am given 1 mole, so that's my N, mole, at standard temperature and pressure. So remember, standard temperature is 0 degrees Celsius. And so that's my T. And standard pressure is 1 atm. Now, one thing I meant to look at back here is, if we look at my gas constant, notice my units is liters. So my volume over here, volume needs to be in liters, has to, because my units have to match. My pressure is in atms. My moles obviously is in moles. And my temperature here is in Kelvin. So that is really important when I come back here, because we just said standard temperature is 0 degrees, but remember, to get to Kelvin, we need to take our Celsius temperature plus 273.15 to get to Kelvin. And pressure we said was 1 atm, which is good. So we're going to say, all right, so this is my pressure. So I'm going to say I have 1 mole. That's my N. My R, I'll write up here what R was. Remember, it was 0.08206. 0.08206. There's our units. And our temperature, again, if I had 0 degrees Celsius, so 0 plus 273.15 would be 273.15 K. So that's my nRT divided by pressure, we said was 1 atmosphere. So if you plug this into your calculator, you'll notice that volume with, again, I've got 3 sig figs up here. 3 sig figs would be 22.4 liters of Cl2. And that number should look familiar, because we just talked about in this last lecture that for every 1 mole of any gas at standard temperature and pressure takes up a volume of 22.4 liters. So hopefully that kind of helps you see that this all works out. Also, another thing I want you to notice is that all of our units are going to cancel out here to give me liters. Notice that I have moles on top and moles in my R constant. I have atmospheres on top, atmospheres on the bottom here. I have Kelvin on the bottom, Kelvin on top there. My only unit left is liters from that gas constant. So let's look at the second problem. So for the second problem, again, wants to know the volume. We have 1 mole, so that's my N. 2.50 atm, so that's my pressure. 500 degrees Celsius is my temperature, but I do need to convert that. So let's do that first. We know that if I take my Celsius and I add 273, so plus 273, I would get a temperature of 773.15 Kelvin. Now let's plug in, we just solved up here, we said volume is equal to nRT over pressure. So let's plug in my N, my moles, was 1.00 moles. My R is 0.08206. And my temperature all divided by pressure of 2.50 atms. And so if we look at all of our units again, I should have moles, moles cancel, Kelvin, Kelvin cancel, atmospheres, atmospheres. So I am getting liters, which is great. And my calculator should give me a number that's 25.37 0.7876 liters. But again, if I want to go back and look at what I'm starting with, so I have 3 sig figs, 3 sig figs, 4 sig figs, so my least would be 3. So I need to round to 3 sig figs. So that's 7, we'll round that 3 up, so it should be 25.4 liters of chlorine gas. All right, let's try another practice problem. This one wants to know the pressure. So again, if we use PV equals nRT to solve for pressure, we got to get rid of volume. So we're given moles, which is N. We're given temperature. I got to convert it to Kelvin. So I'm going to do that right away. 30 plus 273.15. All right, so we did that conversion. And then we have 500.0 milliliters. Now, that's a volume, but remember, my R constant has volume in liters. So let's convert that to liters. Do you remember that 1,000 milliliters are in 1 liter? So I would take 500 milliliters. And remember, I need to have milliliters on the bottom to cancel out. So I would have my 1,000 down there and 1 liter on top. So this would be 0.5 liters. It's kind of sloppy, sorry. So I've got pressure is equal to my moles, which is 1.52 moles. My R and my temperature, 303.15, all divided by a half of a liter. And when we do my math, I should get, looking at my significant figures, again, I have 3 sig figs here, 3 sig figs there, 4 sig figs there, so I want to end up with 3. My pressure should be 75.6 ATMs. And to just double check, make sure that I'm getting ATMs as my answer. My moles and my moles cancels. You see here, liters and liters cancel. Kelvin and, oops, I forgot to label my Kelvin. Kelvin and Kelvin cancel, and I'm left with ATMs. All right, let's do one last practice problem. And this one wants us to find how many moles. So it needs me to find N. So if I say PV equals nRT, remember to have N by itself, I got to get rid of RT. RT. So N is equal to pressure times volume over R times T. Now let's see what variables I have. I should have everything right here. I'm given liters, which is volume. I am given millimeters of mercury, which we know is a pressure, but I need to switch that into atmospheres, remember, because of my R. And I'm given Celsius temperature, and I need to convert that into Kelvin. So let's do temperature right off the bat. So I'm going to add 273.15. All right, so that solves one problem. Next, I need to get my millimeters of mercury. So we're going to say 765 mmHg. And if you look back earlier in your notes, we learned that 1 ATM was equal to 760 millimeters of mercury. So if we do that math, we should just over 1. And I got 1.00657. I'm not going to round yet until I get to the very end. So there's my pressure. Whew, okay. Now we can plug it in. So we said N was equal to my pressure, which is 1.00657. So that's my P, and my V is 2.50 liters. So there's PV divided by R, 0.08206, which is L, liters atmospheres over moles Kelvin, over R times T, 304.15 Kelvin. Okay, now to solve this problem, make sure that you do the two top numbers multiplied by each other, the two bottom numbers multiplied by each other, and then do total top divided by total bottom. And when you do this and we look at what I'm starting with, I have 3 sig figs on top, 3 sig figs for pressure, 3 sig figs for temperature, so I need to end with 3. So we should have, for my moles, 0.101 moles of whatever gas is present. And so with this bit that we've just done through ideal gases, hopefully you understood how to rearrange this equation to solve for pressure, volume, moles, or temperature through the ideal gas law. Hopefully you understand units and understanding that we were able to cancel out units to like, for example, atmospheres, atmospheres, liters, liters, Kelvin, Kelvin, so that we can get whichever unit we're trying to find, and to solve for missing values by using our ideal gas law.